Now, when everybody is gathered here, we will hear a speech by Professor Astrid Söderberg-Wirring, the chair of the board of the Nobel Foundation.
Your Majesties, Your Royal Highnesses, esteemed Nobel Prize laureates, Excellencies, ladies and gentlemen. On behalf of the Nobel Foundation, it is my great honor and pleasure to welcome you all to the 2024 Nobel Prize Award ceremony. In particular, I wish to welcome the Nobel Prize laureates, their families and friends. Today in Oslo, the Nobel Peace Prize was awarded to Nihon Hidankyo, also known as Hibakusha, and I quote, "for its efforts to achieve a world free of nuclear weapons, and for demonstrating through witness testimony that nuclear weapons must never be used again," end of quote. This Japanese grassroots movement, survivors of the atomic bombs in Hiroshima and Nagasaki, has for almost 80 years argued the necessity of an international nuclear taboo. During decades, nuclear arms were considered the main threat to humankind. But in spite of these witnesses reminding us, and because of trust in arms treaties and international developments, this almost fell into oblivion. Today, as nuclear threats are being expressed anew in connection with wars and conflicts involving nuclear powers, the Nobel Peace Prize takes on an existential dimension. Earlier this year, a number of Nobel Prize laureates signed the Mainau Declaration 2024 on nuclear weapons, urging all nations to protect human civilization by ensuring that nuclear arms never be used again. The atomic bomb also recalls that basic research put into practice is not only for good. Still, however, it is through free fundamental research that science must continue to explore and expand the frontiers of human knowledge, laying the foundation for future applications and development. The scientific breakthroughs awarded this year in science and medicine, the Physics Prize for using dynamical systems to understand mechanisms of memory and laying the foundations for artificial intelligence, the Chemistry Prize for using the latter for predicting protein structures and for computational design of proteins, and the prize in Physiology of Medicine for the discovery of an essential complementary process for how identical genetic information leads to different cells, have already led to groundbreaking applications for the greatest benefit of humankind. The unimaginable consequences that genetic technologies and artificial intelligence may perhaps introduce can only be managed in trustful, rule-based international collaboration. The Literature Prize this year, awarded to a profound exploration of human vulnerability against the backdrop of historical trauma, where the abyss is always as close as is the longing for transformation, sheds light upon the fragile condition of humankind. And finally, the prize in economic sciences for quantitatively assessing the importance of a country's institutions for its prosperity can be considered in the present context of ongoing autocratization with faltering democracies. Facing a number of interconnected challenges, including climate change and geopolitical tensions, we indeed live in times of volatility, uncertainty, complexity, and ambiguity. The insightful testament of Alfred Nobel, which has gathered us here, is still of highest relevance. The scientific prizes award fundamental research. Still, all the awards, in their diversity, also address the global challenges of today. The laureates have paved the way. Science, literature, and peace offer different paths to tackle today's wicked problems. But they all remind us that it is not blind destiny that decides on our future as humanity. This also offers hope. It lies in our hands to change the world.
Before the first prize being awarded to the physics laureates, we will be entertained by some music, a piece by Richard Wagner.
Frieden
Toira Haile Elizabeth's greetings from Tannhauser. And soprano soloist here is Ingela Brimberg. Now a presentation speech by Professor Ellen Moons.
Your Royal Highnesses, esteemed Nobel Prize laureates, ladies and gentlemen. As you arrived here today, you recognized some faces instantly, and names came to you in a flash. Other names may have slipped your mind, and perhaps you felt a twinge of frustration, scanning your memory for the circumstances of the past encounters that just won't come into focus. Memory association works as a scaffold to understand new information. With every thought, the billions of neurons in our brain develop stronger connections. In 1949, the Canadian psychologist Donald Hebb said, "Neurons that fire together, wire together," to describe the mechanism of learning. This year's Nobel Prize laureates in physics, John Hopfield and Geoffrey Hinton, were inspired by the network of neurons in the human brain. They developed artificial neural networks, which are fundamental for machine learning, allowing computers to learn without explicit programming. In 1982, John Hopfield discovered that the physics describing how atomic magnetic moments align in solids, giving them magnetic properties, can also be used to describe the interactions between neurons in our brains. He developed a dynamical model for the associative memory based on networks of binary nodes, where nodes were assigned values determined by the weighted sum over all nodes. Like a ball rolling down a hill, the dynamics drive the system into the valleys of the energy landscape, where it relaxes. In these valleys, memories are located as stationary states. So this is where you will find the name of the acquaintance you were searching for in your memory landscape. As a theoretical physicist with deep roots in solid-state physics and a passion for complex processes in biophysics and neuroscience, John Hopfield's achievements are a testimony to the power of interdisciplinary thinking. Geoffrey Hinton extended Hopfield's model using ideas from statistical physics. The invention is called the Boltzmann machine, named after the Austrian physicist Ludwig Boltzmann. It contains multiple layers of nodes, and is trained using given sets of patterns. Once trained, the network can generate new patterns that resemble those in the learned set. Geoffrey Hinton is a leading figure in the development of efficient learning algorithms. He pioneered the efforts to establish deep and dense neural networks. Such networks are effective in sorting and interpreting large amounts of data, and self-improve based on the accuracy of the result. Today, artificial neural networks are powerful tools in research fields spanning physics, chemistry, and medicine, as well as in daily life. while they can aid humans in delivering fast answers, it is our collective responsibility to make sure that they are used in a safe and ethical way. Professor John Hopfield and Professor Geoffrey Hinton, you have been awarded the 2024 Nobel Prize in Physics for foundational discoveries and inventions that enable machine learning with artificial neural networks. It is an honor and a privilege to convey to you, on behalf of the Royal Swedish Academy of Sciences, our warmest congratulations. I now ask you to step forward to receive the Nobel Prizes, your Nobel Prizes, from the hands of His Majesty the King.
Professor John Hopfield and Geoffrey Hinton here first. John Hopfield, and he will receive, well, of course, a diploma and a Golden Nobel Medal from His Majesty the King of Sweden. Standing ovations. What a joyful moment here. And of course now is the turn for Geoffrey Hinton to receive his physics prize. Geoffrey Hinton, by many dubbed as one of the godfathers of AI, that has been vocal in the AI debate recent years as well. One might say that the physics prize this year is sort of a prelude to the chemistry prize, which also bears strains of AI in it, being an AI application of the technology. And we will hear more about this by Professor Johan Åkvist.
Your Royal Highnesses, esteemed Nobel Prize laureates, ladies and gentlemen. Proteins are the macromolecules that enable the chemistry of life. They catalyze all the needed chemical reactions. They also function as signaling molecules, receptors, pumps, antibodies, and building blocks of different tissues. So their diversity is truly remarkable. And to understand how proteins work, you need to know what they look like. So proteins are basically polymers made up from an alphabet of 20 amino acids. And these can be combined in endless ways. A typical protein may contain maybe a few hundred amino acids and thousands of atoms. So their magic derives from the fact that these strings of amino acids fold themselves up into well-defined and complex three-dimensional shapes. Now, even more magically, the 3D structures are somehow encoded in the sequence of amino acids. So a complex three-dimensional pattern is thus encoded in a linear sequence. Hence, it should be possible to predict the 3D structure of a given protein directly from its amino acid sequence. And this 50-year-old problem has been called the grand challenge of biochemistry. However, progress in protein structure prediction was slow for many years. But one can also turn the problem around and ask, given a certain 3D structure, what amino acid sequences would fold up into this structure? This would enable the design of completely new proteins. And David Baker showed in 2003 that it was possible. He could design new structures that had never been seen in nature before and compute what sequences would give these structures. He could then experimentally verify that the computational predictions were correct. So this is what we now call computational protein design. And following the first breakthrough 20 years ago, David Baker has designed a multitude of new proteins with many exciting applications. Virus inhibitors, nanomaterials, protein switches, and sensors, just to mention a few. Now, the reverse problem of predicting the three-dimensional structure directly from the amino acid sequence, it had to wait until the year 2020 for the real breakthrough. And this was when Demis Hassabis and John Jumper and their co-workers had developed the now famous AlphaFold 2 computer program. It basically cracked the code. AlphaFold is an ingenious piece of neural network engineering that showed unsurpassed performance in protein structure prediction. And utilizing the vast amounts of experimental data stored in structure and sequence databases, the network is trained to discover correlations and patterns among amino acid sequences. This enables it to produce astonishingly accurate structural models directly from the sequences. It's really no exaggeration to say that AlphaFold has caused a revolution in structural biochemistry. David Baker, Demis Hassabis, and John Jumper, your groundbreaking work in computational protein design and protein structure prediction has revolutionized these fields. It has opened up completely new possibilities to design proteins that have never been seen before, and we now have access to predicted structures of all 200 million known proteins. These are truly great achievements. On behalf of the Royal Swedish Academy of Sciences, I wish to convey to you our warmest congratulations. May I now ask you to step forward and receive your Nobel Prizes from the hands of His Majesty the King.
David Baker, first to receive his chemistry prize for his groundbreaking research, and then we have what might be called a true a prize. Well, this is a prize in true Nobel spirit. For you might call the AlphaFold AI model an invention, in the same way as Alfred Nobel once envisioned his prize to be awarded to the people who had done the most use for humanity during the past year. Well, this invention, AlphaFold, is 4 years old. Very young to be a Nobel Prize material. Yeah, that's a real prize. To John Jumper, the colleague of Demis Hassabis, who just stepped forward before him to receive his Nobel from the hands of His Majesty the King of Sweden. Family, colleagues and friends invited are sharing this glorious moment. And before we move on to physiology or medicine, let's have a break with some more music by Arnold Schönberg. If you have wondered what the Nobel Prize in Physiology or Medicine is about this year, wait no more, because here is the presentation speech by Professor Richard Sandberg from the Nobel Assembly at Karolinska Institutet.
Your Majesties, Your Royal Highnesses, esteemed Nobel Prize laureates, ladies and gentlemen. For a moment, I invite you to look around this majestic hall. Imagine that we are not in a concert hall, but inside a human cell. Look at the wonderful orchestra behind me, representing our genetic information, our DNA. Now let each musician with their respective instrument correspond to a single gene. In a real cell, however, there are about 20,000 such performing genes, each playing a tone and rhythm for different cellular traits and functions. For an orchestra of this magnitude, effective conducting is naturally very important. For decades, it was known that proteins called transcription factors were conductors needed to guide the cellular symphony by amplifying or dampening the performing genes. This year's Nobel Prize in Physiology or Medicine is about the surprising discovery of a novel type of conductors called microRNAs that provide additional and crucial guidance over the cellular orchestra. MicroRNAs are conductors with a special ability. Instead of passionately making gestures to either amplify or dampen music intensity, microRNAs tell musicians only when to quiet down or take a break. You there, play softer. You take a break. Victor Ambros and Gary Ruvkin investigated how genes control organ development in a 1 millimeter long worm. More than a decade of persistent research led them to discover the first microRNAs and to discover how microRNAs control gene activity. MicroRNAs bind messenger RNA, the intermediate carrier of genetic information from the DNA to protein production, thereby reducing protein or messenger RNA amounts. Their groundbreaking discovery in a small worm had major implications for humans and all multicellular life. MicroRNA genes were soon found across animals and plants, and even in certain viruses. In fact, animal microRNAs arose around 600 million years ago, when cells organized into more complex life forms, and microRNAs expanded in numbers in their genomes. The human genome contains around 1,000 microRNAs that control the activity of other genes through embryonic development and in adulthood. You there, play softer. You take a break. The laureates are excellent examples of how curiosity-driven basic research, exploring fundamental questions about cellular and organismal function, can advance our understanding of physiology and medicine in ways that couldn't have been predicted. Basic research is the driver of biomedical knowledge. Thanks to the groundbreaking discovery and research performed by Ambros and Ruvkin, a highly unexpected yet crucial layer of gene regulation was uncovered that is essential for complex multicellular life. The microRNAs regulate the activity of other genes to keep us alive and thriving. The laureates have revealed that sometimes the most beautiful cellular music comes not just from knowing when to play, but knowing when to be quiet. Dear Professors Ambros and Ruvkin, on behalf of the Nobel Assembly at the Karolinska Institutet, it is my great honor to convey to you our warmest congratulations. And I invite you now to step forward to receive the Nobel Prize from the hands of His Majesty the King.
Sings the most beautiful cellular music comes not just from knowing when to play, but knowing when to be quiet. I will do just that and let you listen to some nice music instead. Soloist Ingela Brindberg performed A Letter Arrived by Gunnar de Frumery with lyrics by Per Lagerkvist, a former Nobel laureate, author receiving the Nobel Prize in Literature in 1951, and now for the Literature Prize 2024.
Ärade pristagare, mina damer och herrar. Två färger möts.
Two colors meet in Han Kang's writing, white and red.
Det vita är
The white is the snow that falls in so many of her books, drawing a protective curtain between the narrator and the world. But white is also the color of sorrow and death. Red stands for life, but also for pain, blood, the deep cuts of a knife. While her voice can be seductively soft, it speaks of indescribable cruelty, of irreparable loss. Blood flows from the bodies piled up after the massacre, darkens, becomes an appeal, a question that the text can neither answer nor ignore. How should we relate to the dead, the abducted, the disappeared? What can we do for them? What do we owe them? The white and the red symbolize a historical experience that Han returns to in her novels. We do not part from 2021. The snow creates a space where a meeting can take place between the living and the dead, and those floating in between who are yet to decide which category they belong to. The entire novel is played out within a snowstorm, where, in piecing together her memories, the narrative self glides through layers of time, interacting with the shadows of the dead and learning from their knowledge. Because ultimately, it is always about knowledge and seeking out the truth, unbearable though it may be. In one exquisitely realized evocation, the friend, despite her physical body being confined to a hospital bed many miles away, is able to pull out a box of files from a shelf and find a document that adds a further piece to the historical mosaic. The dream spills over into reality, the past into present. These shifts, by which boundaries are dissolved, are a constant in Han's writing, where people move around unhindered, their feelers pointing in both directions, ready to gather and interpret signals. Perhaps they are broken down by what they see and witness, which always comes at the price of their own peace of mind. And yet they keep on going with the strength that is required. Forgetting is never the goal. Who killed me? Asks the murdered boy's soul, as the facial features that defined him in life dissolve and disappear. For the survivor, the question is a different one. How can I live on with this body that has only led me to torment? How can I regain the body that torture has reduced to nothing but a bleeding object? But when the body gives up, the soul continues to speak. When the soul tires, the body keeps on walking. Deep within lies a stubborn resistance, a quiet insistence stronger than words, a need to remember. Again, it is not the aim to forget, nor would it be possible. In Hans world, people are wounded, fragile, in some sense weak, and yet they possess just enough strength and just the right kind of strength to take another step or ask another question, request another document or interview another surviving witness. As the light fades, the shadows of the dead continue to move around on the wall. Nothing ever passes. Never, ever ends.
Dear Hangang, on behalf of the Swedish Academy, it is my privilege to convey to you our warmest congratulations on the Nobel Prize in Literature 2024. May I now please ask you to step forward and receive your prize from His Majesty the King.
And this presentation speech by Ellen Mattsson, a member of the Swedish Academy, that has awarded Han Kang the Literature Prize 2024. Leading up to the final prize, we will enjoy a short musical interlude. Performed by the Royal Stockholm Philharmonic Orchestra under conductor Johannes Gustafsson. Varvalia, a Dance by English composer Ruth Gibbs. And now to the prize in economic sciences, where two of the laureates are from Great Britain originally. And the presentation speech is presented by Professor Jan Thorell.
Your Majesties, Your Royal Highnesses, esteemed laureates, ladies and gentlemen. Not long ago, Sweden was a poor country, run with societal institutions only benefiting a narrow elite. Today, however, Sweden is one of the few lucky countries in the world enjoying both inclusive institutions and economic prosperity. Sweden has it all. So, if you come from a country like Sweden, you may think it obvious that institutions cause growth. But because we have it all, this is actually far from obvious. How can we be so sure it's not the other way around, that we can afford these inclusive institutions because of our economic prosperity? Or maybe, by some strike of luck in the distant past, some other underlying factor gave us both the institutions and our prosperity. In a very innovative move, this year's laureates solved this empirical conundrum by studying a huge intervention in human history, the colonization by the Europeans of large parts of the world, starting in the 16th century. By creatively using historical data on how vastly different the institutions were that emanated from this colonial experience, they were able to provide solid evidence for a causal effect of institutions on growth. But their contribution was not only empirical. Through a series of original game theoretical models, they were also able to explain why institutions are so difficult to change. And these insights, as it happens, actually apply directly to the case of Sweden. Not far from here, in December 1918, the Swedish Parliament, on a late December night, about as cold as this one, passed an important government bill to secure both female and equal suffrage for the Swedish population. This particular decision can be seen as the eclipse of a series of reforms of both the political and economic institutions of Sweden. But the decision didn't come lightly. The conservatives, whose economic benefits were on the line, fought hard against it. In the end, on that cold December night, they accepted defeat. Why did they? The short answer is to thwart an imminent threat of revolution. The political situation in Stockholm at this time was tense as a bowstring. The year before had seen the Russian Revolution. Also in neighboring Finland, a civil war was raging. And then in early November 1918, the abdication of the German emperor sent shockwaves throughout the continent that also reached the Swedish capital. At this moment, the Swedish military conscripts were effectively disarmed, and an armored boat with a loyal crew moored in the waters close to the Swedish Parliament building. Yet, the conservatives understood a crucial thing. They couldn't sweet-talk themselves out of this situation. Simply promising future welfare reforms for the material benefit of the general population wouldn't do the trick, because everyone understood that come the day when the situation had calmed down, such promises could easily be broken. Thus, the only way to appease the masses was to relinquish power itself by extending the franchise. The more general significance of this so-called commitment problems has also been highlighted by the laureates. And it helps us understand not only why institutions are so persistent, but also why they sometimes, as in Sweden in 19, change. Professors Acemoglu, Johnson, and Robinson. These contributions are also of practical importance. because the huge and persistent income gap between the poorest and richest countries in the world has enormous consequences for billions of people living in the world today. And your work shows that promoting democracy and inclusive institutions is an important way forward for closing this gap. So, it is my honor and my privilege to convey to you, on behalf of the Royal Swedish Academy of Sciences, our deepest and warmly felt congratulations. Now, please step forward and accept the prize from His Majesty the King.
And first laureate to do so is Daron Ajamoglu, with a Turkish-Armenian background, who moved to Great Britain early in his life for studies, and since many years is an American citizen working at MIT in Boston. At which institution also Simon Johnson is affiliated. Simon, who, when he doesn't do research, is a great football fan. And of course, Sheffield Wednesday is his team, just as his father's, I understand. And James Robinson at the University of Chicago, a great aficionado, or I don't know what to say. The correct word would probably be very interested in everything that has to do with African culture and history. Many of the historical perspectives in this research are probably due to him and his interest in that. And now it's time for the awards ceremony to conclude. Was the Swedish national anthem. And now the Queen of Sheba's Festivity March from the Prodigal Son by Hugo Alfvén is played while the guests are leaving the auditorium. And to that music, I wish to thank you very much for joining us here in Stockholm today on the 10th of December for the 2024 Nobel Prize Awards ceremony.